oleh beliau bisa kita pahami dengan baik dan bisa kita bayangkan betapa besarnya kepedulian beliau atas tanggung jawab ilmu yang beliau miliki, dan ini juga tentunya ada pada diri kita semua. Kita memiliki hal yang berlebih karena kita memiliki pengetahuan dan juga kita berada di negeri ini. Tentunya apa yang diusahakan oleh Prof. Ron ini harus bisa memotivasi kita untuk bisa melakukan banyak hal buat negeri ini. Itu yang ingin saya sampaikan. Sekali lagi terima kasih banyak dan saya ucapkan selamat mengikuti ceramah dari Prof. Ron. Semoga kita semua bisa mendapatkan pelajaran yang baik dari kegiatan ini. Demikian, Assalamualaikum.
Thank you, Dr. Insinyur Utragasi Hamasi, for the opening remarks. Next, allow me to invite Dr. Iman Suwardi, MSc, ex-head of Geophysics Department in STMKG, on behalf of Director of STMKG, to deliver opening remarks. Please give a warm round of applause to Dr. Iman Suwardi, MSc.
Cek, oke. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Selamat siang, salam sejahtera buat kita semua. Saat ini, kebetulan Ketua STMKG lagi ada meeting dengan BPK, jadi saya mewakili beliau untuk memberi sambutan dalam bahasa Inggris untuk Profesor Ron ya, dari BYD ya. Okay, bismillahirrahmanirrahim. Good afternoon, everyone. Welcome, delegates from BMKG, BNPB, HAGI, and SIG. It's truly an honor and a pleasure to welcome you all to this important seminar. One of SEG Seismic Gap Tour program with theme Bridge over Troubled Waters, experiments with full spectrum Geohazard risk reduction in Indonesia. To our distinguished guests, esteemed speaker, dedicated practitioner, researcher, student, and all participants joining us today, a very warm welcome. Especially to Professor Ron Harris from Brigham Young University, USA, who is an expert in plate tectonics and geophysical hazards, dedicated to applying geoscience for social benefit. We are gathered here in Tangerang, Banten, Indonesia, a nation renowned for its breathing natural beauty, but also one profoundly shaped by dynamic geological forces. From the majestic volcanoes that do our landscapes to the active seismic belts that crisscross our archipelago, Indonesia is a living laboratory of geohazards. Earthquakes, tsunamis, volcanoes, also volcanic eruption and landslides are not just abstract concepts for us. They are realities that have probably impacted our communities and our development. The title of our seminar, Bridges over Troubled Waters, is more than just a metaphor. It speaks to our collective endeavor to build resilience, to connect communities, and to develop robust strategies that can withstand the forces of nature. The troubled waters represents the inherent risks and uncertainties posed by geohazards, while the bridges symbolize the innovative solutions, collaboration effort, and the steadfast commitment required to navigate this challenge safely. Today, we will delve into the experiments with full spectrum geohazard risk reduction. This isn't just about single solution. It's about a comprehensive approach. It encompasses everything from the latest advancements in early warning systems and resilience infrastructure to empowering communities through education and preparedness, integrating traditional wisdom with cutting edge technology and shaping effective policies. These are real world experiments, often challenging, sometimes groundbreaking, and always driven by the goal of protecting lives and livelihoods. This seminar offers a crucial platform for us to share knowledge and experiences, learning from the successes and challenges for faced in various initiatives across Indonesia, foster collaboration, connecting individuals and organizations to build stronger partnership, inspire innovation, exploring new ideas and technologies to enhance our risk reductions effort. Your presence today signifies a shared commitment to building a safer, more resilient Indonesia. Every contribution, every question, and every insight shared will add to the collective strength of our nation in facing these natural challenges. I encourage you all to engage actively, learn from our distinguished speakers, and participate wholeheartedly in the discussion. Let us use this opportunity to forge stronger bridges of knowledge, partnership, and resilience. Thank you for being here, and I wish you all a productive and inspiring seminar. Thank you very much. Wabillahi taufiq wal hidayah. Wassalamualaikum warahmatullahi wabarakatuh. Terima kasih.
Thank you, Dr. Iman Suardi, MSc, for the opening remarks. Before we start our seminar, let us take a picture together, both offline and online. May I kindly ask everyone in this room to gather in the center so we can take a group photo together. And for our online participants, please turn on your cameras for a moment so you can be part of the group photo as well. The photo will be taken from the stage. Please give your best smile. On count. 3, 2, 1. Once more. 3, 2, 1. Okay. On count 3, 2, 1. Okay, thank you. Okay, ladies and gentlemen, the heart of today's seminar lies in the exchange of knowledge and the sharing of experiences. To guide us through this intricate and vital topic, we have an exceptional individual who possesses not only deep expertise, but also the remarkable ability to facilitate engaging and provoking discussion. It is now my immense pleasure to hand over the session to our esteemed moderator for today, Ms. Ayu Adi Justicia, STSSD Magister of Applying Science. She's a renowned geophysics department lecturer expertise in remote sensing, especially in earthquake precursor and tsunami precursor. Geohazard expert, researcher, practitioner in disaster risk reduction. We are truly fortunate to have her lead our discussion. Please join me in giving a very warm welcome to Ms. Ayu Adi Justicia, ST Magister of Applied Science.
Okay, Assalamualaikum warahmatullahi wabarakatuh. And good afternoon, everybody. Thank you, Kadit Dila, for that very kind introduction. Good afternoon, everyone. It's true to be pleasure here, serve as your moderator for today. Our exciting seminar themes about the bridge over troubled waters, which means experiment for with full spectrum geohazard risk reduction in Indonesia. As Kadet Dila has rightly pointed out, that Indonesia is a living laboratory for geohazard. And that's because we are living in the ring of fire area, especially in Indonesia. That's why our landscape is dynamic and constantly evolving. And unfortunately, we also have many geohazards in Indonesia. Give us warm applause for Professor Ron A. Harris for today's seminars. As we know, Professor Ron A. Harris is a leading expert, especially about plate tectonics and also geophysical hazard, right, Professor? And then applied geoscience, which means for social benefit. That's why we give a round of applause once more to start our seminar today. Time is yours, sir.
Terima kasih banyak. Terima kasih untuk Suardi to Cariano, and Ibu Ayu, and to the Taruni and Tarana. Did I say that right? Taruni. Yeah. I'm very grateful to see for the first time the approach that you have to addressing the problem in Indonesia of natural hazard risk reduction. It's going to take a military approach. So to have the geophysics very, very appropriate, because it's going to take an army to protect us from these natural hazards. Indonesia is a country that is surrounded by troubled waters. The troubled waters are caused by earthquakes and landslides and volcanoes, which create tsunamis. And Indonesia, over the last 400 years, has had a tsunami once every 4 years. There's no other place on earth like that. Not even close to that. And so if we just focus on tsunamis first, that would change a lot of the losses that we experience to nature. For example, the one big tsunami in 2004 took over 270,000 lives. That overwhelmed almost all of the losses for decades that we had had in Indonesia. And that is just the beginning. The 2004 event was just the beginning. We also have, that was a large seismic gap that we had that then ruptured and caused the big tsunami. We also have 5 other seismic gaps in Indonesia. Each one of them could produce a magnitude 9 event. Is Indonesia ready for this? Could anybody be ready for this? That's why it's so important that you're here, is because we need your help. We need you to be the next defense, not against the Dutch, not against the Japanese, not against the communists. We need you to be the next army front against natural hazards, to bring reduction of risk. When you're prepared, you're not afraid. So what your job is to extinguish fear among the people of Indonesia. When I see you, I'm not near as afraid of these natural hazards as I would be without you there. You're playing a key role in protecting your country and your own communities that you live in. This is the first time a place like Indonesia has had the approach that you're taking. Is it going to work? It's an experiment. We don't know. But we're going to do all we can to try to get the upper hand on nature by preparedness, not by waiting until something happens and then going in afterwards to clean things up. And it's to go in before. It's called proactive versus reactive. Proactive disaster mitigation. That's what bridges are. They're proactive. You're like, okay, we've got to connect these 2 pieces of land. We're going to build a bridge to do that so that there can be interaction. The bridges that you're building are very important because you're connecting highly sophisticated scientific knowledge to the people who are in harm's way. You're helping them to understand what you're learning in classes. Not all of it, just enough of it so that they can recognize when they're in danger and they know what to do to reduce that risk. We call it response efficacy. People know how to respond when they see a hazard or when they are informed of one. That's what people didn't have in 2004, was response efficacy. After the 2004 earthquake and tsunami, there were surveys done of the people who survived. 96%, almost all of the people who were surveyed, over 600 people were surveyed, said they had no idea that there was a connection between an earthquake that shook for 13 minutes and a tsunami. 7 years later, there was a big tsunami in Japan in 2011. After that tsunami, only 20,000 people were killed. So less than an order of magnitude, less people died. When they were surveyed after that tsunami, 96% of them knew that there was a connection between the the tsunami, and the earthquake. That's why they survived. Simple education. And so that's what I'd like to talk about today. Do you have oh, right here. Okay. Can I walk around? Okay. Let's see if I can figure this out. Is it like, this is the pointer? Or, oh, that goes back and forth? Okay. And is there no pointer? Okay, I'll just point. Okay, so thank you for the, oops. And Purna, in the middle of a rice field, looking at a core to try to see if we could find evidence for tsunami. And when we put that auger down into the mud, we find areas of high energy sand with marine organisms in them. So we know it had to be a tsunami. We also do high resolution GPS measurements. We also do shear wave measurements to see which areas are more stable to build at and which are not. So we can make a map before people build. We can have an idea as to how they have to build, whether high buildings or low. Okay. And so these are all ways that we can assess the risk. Okay, next slide. Okay. You need to, can you stay in, there we go. Okay. So this is a map, a tectonic map of Eastern Indonesia. And this is an example of how we use historical data to reconstruct where earthquakes were in the past, before we had instruments like you are using now, before we had seismometers, we have to use the accounts of the people that are there. We call them human seismometers because they provide information for us so we can reconstruct how large the earthquake was and where it was. So this is an earthquake that happened in 1852 in the Banda Sea. All of these red dots here are places where people recorded the earthquake, and they also recorded a tsunami. And they indicate in their record the time difference between when the shaking was and when the tsunami arrived. We know how fast tsunamis move, so we can reconstruct that distance. So we can draw a circle. If we think that the tsunami was 200 kilometers away, we can draw a circle 200 kilometers around that one, around where all of those meet should be where the tsunami was. And the height of the tsunami can also tell us how large the tsunami was. And we can then use that to determine how large the earthquake was. So what we did with this is we used a statistical approach called a Bayesian statistical approach, which is, okay, what are the possible places where that earthquake could have happened? Well, we see this big subduction zone here. We see another subduction zone here that goes like this. We see some smaller faults. None of these are large enough to create a tsunami that was recorded in those dots. So we likely had the earthquake had to come from these large faults. And so, next slide. So this is the area that we wanted the computer to search. So the computer was using data from all of those red dots there, and it would start a point, and the point would move in the direction of higher probability. And so after running this for 2 months, this is what it produced right here. It says that none of the earthquake could not have been over here or over here to satisfy the observations. It had to be right there. So this is very powerful. Now we can extend the record of seismic history for Indonesia back hundreds of years because of these historical accounts. That's important because a seismic gap is a place where you have pressure building, but you're not having any earthquakes. And that's because earthquakes happen on a cycle. Okay, so once an earthquake happens, it releases the energy, it releases the stress, and it starts to accumulate stress after that. So if we know when the last earthquake was, we can then predict how much energy has been accumulated since the last event. Why? Because we know how fast the plates are moving. And we know when the last event was. The last event was right here in 1852. So how much energy has accumulated since 1852? Well, that earthquake was in 1852, so that's been hundreds of years since it happened. And the rate of plate motion there is about 7 centimeters a year, or 7 meters per 1,000 years, right? And so it's accumulated probably at least another 10 meters or 15 meters of strain. So if it happened right now, it would be another magnitude 9. So we call this now casting. It's what meteorology uses, right? Now casting to try to make a forecast for the weather. Well, we can now use now casting for earthquake forecasting. So we can say, okay, this will likely have an earthquake and a tsunami in the next 50 years. It could be today, it could be in 50 years, but it's likely it's gone full cycle. Okay, next slide. Okay, so this is what seismic gaps are. So this is a subduction zone right here. This is actually one in Japan, but it doesn't matter. It applies to Java as well. This area right here is the area that's stuck. Like if you push your hands together, your fingers get stuck on the lower hand, and you can feel the pressure build. And eventually it gets too high that this springs back. So this area right here is being pushed away by this subducting plate right here. It's stuck right there. This is too warm for it to get stuck. There's not enough pressure here for it to get stuck. And so you can see this arrow right here showing that this part of the upper plate is moving faster than those arrows right there. And so you're bunching up energy here. You're bunching up energy like this. And eventually it's going to snap. Okay? And so this patch right here, the larger that patch is, the larger the earthquake is. So here's some patches. This part right here broke in 1861. And just by doing the physics, we think was an 8.5. This one right here, right around the turn of the 18th century, was an 8.2. This one right here, a 9.0. No major earthquakes in this seismic gap. This is Java. This is where we are right here. And there's a big seismic gap here that doesn't have anything that we know for at least the past 500 years. This is a project that Hanif worked on with me, where he went all along the coast of Java, Bali, Lombok, and looked for evidence of an earthquake that happened in the last 500 years, a megathrust earthquake. Couldn't find one. So this has been accumulating strain for 500 years. This one over here was even larger amount of accumulation. So we had two seismic gaps. Next slide. So this is part of Hanif's work. These are all the places we visited in Java, Bali, Lombok, Sumba, Timor, Leti, Moa, Kisar, Ambon, and the Banda Islands. So in each one of these places, we would dig a hole and see if we could find a tsunami deposit. Next slide. This is, sometimes the river would dig the hole for us, okay? So here's a riverbank. Here's a tsunami deposit we found that was about 500 years old. This one right here, about 1,000 years old. These were dated by Professor Yulianto. And so this is, the black would represent mud, the yellow would represent sand, and then mud, and then sand, and then mud. And these sands have marine organisms in them. So this sand had to have come from a tsunami. Okay, this is GPR. We used it, is that you, Hanif? Oh, okay. We used the GPR to see if we could find these sand layers under the ground and track how far they went. But it didn't work very well because the ground is too wet. And if you know anything about GPR, that's not the right condition to use it in. But we tried. Okay, next slide. This is in a village in Ambon called Galala. They had a historical account of a tsunami in 1950. And we found that tsunami right below the surface right here. And we also found evidences of 3 other tsunamis below that. So Ambon gets blasted with tsunamis about every 50 years. And it's been over 50 years since the last one. It's been 75 years. Okay. Here's one of my students measuring uplifted coral terraces. These used to be underneath the water and now they're uplifted over 15 meters, probably by big earthquakes. Okay, next slide. All right, this is an animation. Can you click on this right here? Put the pointer right here and click. Yeah, bring the point down. Click on that. Oh, it's not. Movies aren't working. Okay. What this was going to show, when a tsunami comes in, it takes all of this sand right here and it moves it on top of the soil right here. If there's areas in here where you have low areas, it'll deposit sand and then the sand will get buried by mud again. And so tsunamis leave a trace of themselves. You can see this one right here. This is this 2004 tsunami in Sumatra. You can see there's another one about 1,000 years earlier, another one about 1,500 years earlier, another one about 2,000 years earlier. So about every 500 years, there's a major tsunami. Okay, next slide. All right, so this is from Hanif's work, where he found tsunamis, one that was about a meter below sea level, or a meter below the surface, and another one about 2 meters below the surface, in all of these places, meaning that there had to have been huge tsunamis at least twice that not only just affected Java, but affected all of Nusa Tenggara as well. And so this one's 500 years old, this one's 1,000 years old, roughly. And so that means that it's already been 500 years since these happened. And so they're likely to happen again. So this is the enemy. You're the geophysical core who's going to be out in the forefront trying to prepare all of these people for this next tsunami that's going to come. It's not a trivial task. It's a very, very difficult task. Ask Hanif. He worked on it for 3 years. And he did a great job. This also shows where we've had major earthquakes and tsunamis in the past and when they happen. You can see that there's areas where there's seismic gaps, like right here in Manado. Why are we going to Manado? Because there hasn't been an earthquake right there for a long time. A lot of energy bill. Why are we going to Ternate, which is right here? Because they've had big megathrust earthquakes and tsunamis on both sides, but it was over 150 years ago, 170 years ago, okay? Why are we going to Timor? Because, and why did we go to these areas? Because there hasn't been an earthquake in here for 500 years. And the people, most people don't know that. Okay. What I put here is the forecast. So this plate boundary right here is 5 centimeters per year, which means that since the last string of earthquakes, it's accumulated 20 meters of strain. That means when the earthquake finally happens, the land will shift 20 meters at nearly the speed of sound. Okay? You can see that this one right here, 3 centimeters per year, has 15 meters of strain. But look at the Java Trench. 7 centimeters a year. In the last 500 years, it's accumulated over 30 meters of strain. This is where the next attack is going to be. Are we ready for that attack? Really, are we ready for that attack? Okay. Next slide. Oh, this is a movie, but it's not going to work. One of the things that we've found, especially Hanif, is, go back, is that when a tsunami comes, a lot of times the deposits it makes out here get eroded away. But what these big tsunamis also do is they take huge boulders that are out here, rips them off the seafloor, and carries them up and stacks them on top of one another. You can see how big some of these boulders are. Look at this accumulation of boulders here. So these are durable. They don't erode away. They sit there as evidence that there's been a huge tsunami. And Hanif got ages on some of these. Most of the ages cluster. If these were storms, they wouldn't cluster. So they cluster around again, 500, 1,000, 1,500 years old. Next slide. So here's an example of us surveying in these boulders, imbricated boulders, from a tsunami. Next slide. So from these data, we can make models. This is our tsunami model, because this whole area right here in yellow has not ruptured in the last 500 years. It's already accumulated 30 meters of strain. So we put into the program 30 meters of strain, right? This is the disturbance. This is the troubled waters from this earthquake. And this is what they do to the land. This is the run up in the land. You can see that the red bar right here is the maximum height of the run up. And the blue bar, the blue bar is the maximum run up, so 22 meters. Pachitan, 13 meters, 19, 26 meters here at Chilachap, 22 meters here. These are huge waves. There's over 6 million people that live in the inundation zone of this earthquake. What are you going to do to help those people? First of all, they need to know that they're in danger, and most of them don't. Most of them don't know the enemy's coming, right? If you ask them, when's the enemy going to come? What enemy? They would say, the tsunami. It's a wave that eats people. It's like Godzilla. Yeah? Okay? And there's a lot of people here to eat that live right in this inundation zone. Okay? This is the number of people in pink that live in the inundation zone. And this one, it's 16,000 people in Bali live in the inundation zone. Actually, I thought it was higher than that. Oh, right here, Denpasar. 600,000 people live in the inundation zone here. Okay, next slide. This is a detail of each of these communities. Here's Bali right here. There's the international airport right there. You can see that the wave is going to come in and wrap around from this way and take out this whole area right here. How long do the people here have to get out of the way? Well, we did a time series here that shows when the wave arrives. So this is when it starts. This is 30 minutes right here. So it arrives, it's going to go out and then it's going to come back in. It's going to go out and come back in. About every 30 minutes, you're going to have another wave. So these waves are at least 20 to 30 meters high. You have 20 to 30 minutes to get away from the coast. There is no way the people who live right here can get out of harm's way unless they build a vertical evacuation site. Well, guess what? There's hotels all through here that are at least 5-6 stories high. And so that could be a way to get out of harm's way, is to go in this. But when we went to Bali and we started talking to people, they're like, no, we're not at risk. I'm like, how can you say that? Because God's going to protect us. And I'm like, God will protect you after all you can do to protect yourself. Yeah. You can't just do nothing and expect God to protect you, right? At least the God I believe in would not just give it to me. He would say, you have to do your work first and then I'll help you, right? Otherwise, we all get lazy. Okay, next slide. This is an animation that shows it coming in, but the animations aren't working. Next slide. So this is the area in Pachitan in Jawa Timur. And this is an app we've developed that helps you to determine what is the best way to escape from wherever you are. And it's still in a beta version, but no matter where you are in Pachitan, you can open this app and it'll tell you where to go to get away from the tsunami, the closest route, and it'll tell you the elevation. And it's not scaled up yet, but eventually this will be available. This can tell you where to go when the enemy attacks. Next slide. This is another very important bit of information that you need to tell everybody about. Based on those models I showed you, they showed that you had 20 minutes before, after you feel the earthquake, you have 20 minutes before the wave arrives. Okay? If the earthquake is 20 seconds long or more, that means it's big enough to create a tsunami. So I started in the wrong place. So when you feel the earth shake, even if it's not intense, even if it's like this, if it lasts for 20 seconds, that's a big earthquake. Because the earthquakes rupture at 5 kilometers per second. And so that would be a 100-kilometer rupture, right? Even if it's just like this. Most tsunami earthquakes have very low wavelengths, and so they're not intense. Some people don't even feel them at all. And so it's not an intense one, it's just 20 seconds. It's the amount of time it takes for it to shake, okay? If you feel an earthquake this 20 seconds, actually, I'm the kind of person, if I feel an earthquake at all and I'm at the coast, I take off. I don't care if it's 5 seconds or 20 seconds. I'm out of there. And I'm telling everybody else, look, there was an earthquake, we need to get out of here, okay? 20 minutes to get to safe ground, and safe ground is probably around 20 meters. Some of these areas, the tsunami is going to be higher than this. So you don't just stop at 20 meters. You just keep going until you can get away. Another thing is to have an earthquake alarm. This is a pendulum that hangs there. There's 2 sensors on either side. The P wave of the earthquake comes through and activates that sensor before you can feel the S wave. The further you are away, the longer the amount of time you have between when the P wave arrived and when the S wave is going to arrive. Yeah. This can save thousands of lives, especially if you live in a house that's not built to seismic code. As soon as this goes off, you get out of there. Next slide. Okay. When we started to go to cities to see what they had done to prepare, we found these signs everywhere. But sometimes they pointed towards the coast. And sometimes they pointed towards a school. And we asked them, what's the plan? Well, the plan is for everybody to go to the school, even though they're going towards the beach, and to wait there for a truck to come and pick everybody up and then truck them away from the beach. We're like, no. You don't have time for that. The enemy's going to arrive before you get anybody in the truck, right? And so what I did in PowerPoint is I pasted these signs underneath these, because these signs tell you what you need to do to survive a tsunami. These signs don't. Some of them point the wrong direction. They don't tell you you only have 20 minutes. This is something you can do to prepare the people for when the enemy comes, is you can say 20, 20, 20, right? And it wasn't us that came up with this. It was our social science friends who said, you need something very, very simple. And we came up, we put all of tsunami science into 3 numbers, 20, 20, 20. 20 seconds of shaking, 20 minutes to get out of the way, 20 meters elevation. Next slide. We've published papers on this, okay? These are papers on different tsunamis, 1629, 1852. And so we have lots of journal articles explaining this. These are like the instruction manual for the soldiers who are going to fight the geophysical hazards. Next slide. Okay, let's talk about what happened in 2004. This seismic gap went, next slide. Before it happened, in 2002, one of my colleagues at UPN University in Jogja and I wrote this But the most dangerous seismic gaps in Indonesia exist in populated regions of Western Sumatra. The entire 1,600-kilometer length of the Sumatran fault system has not slipped significantly for 130 to 150 years. Since this time, 7 to 8 meters of potential slip have accumulated and will most likely be released suddenly to produce a magnitude 8 plus. This forecast was made by simply knowing when the last earthquake was and what the loading rate is currently. Okay? The forecast was okay. We were an order of magnitude off on the size of the earthquake, but it was in the right place. We published it, but nobody had access to the publication, right? We have blood on our hands from this. What we should have done was gone to the Sumatran coast and gone from village to village to village to village to village, explaining this in a way they could understand, so that when they felt the ground shake, they would evacuate. Remember, 96% of the people in the Aceh earthquake had no idea that the earthquake was the warning, that the enemy was coming. Next slide. So this whole thing broke, and then you had a bunch of other earthquakes all through here. But notice, we still have this seismic gap, and we still have a seismic gap right here. This is Padang, this section of the Sumatran subduction zone, which had produced a 9 in the past, has not ruptured for over 300 years. So we have 2 huge seismic gaps. This is where the enemy is going to attack. They're going to attack here, and they're going to attack here. This is a strategic map of trying to protect the people of Indonesia. Next slide. So these are the current seismic gaps right here. Next slide. All right, next slide. Okay, so I want to emphasize that just trying to assess the risk by historical accounts, geological record, seismographs, and I forgot what Paramalan is. Forecasting. Thank you. It doesn't save lives. This is what the full spectrum part of the title is about. It doesn't save lives. What saves lives is if this information goes across the gap to the people who are in harm's way. Next slide. So the highest survival rate during the 2004 tsunami were by the sea gypsies. No formal education, right? No house. The boat is what they live on, right? But they had a myth about laboon, which is a wave that eats people. And so when the ground shakes, they immediately go to the hills and they stay up there for a whole day before they come back down. It's just part of their training. They have no idea about the science of tsunamis. They have no idea that an earthquake happened and a tsunami's coming. They had no idea about any of this, yet they had the highest survival rate. Why? Because the assessment didn't matter to them. They knew that there had been earthquakes in the past, and they created tsunamis. And so when they feel the earthquake, they self-evacuate. Do they need a warning from the government? No, they don't need a warning from the government because they know the signs. Do they need somebody to tell them which way to go? No, they already know which way to go, right? Because they do tsunami drills. They don't call them tsunami drills, they call them laboon drills.
awareness on people who doesn't already aware of the danger, such as tsunami, like in the case of Bali, in which they believe that God will protect them. How we can at least persuade to manage to make them put the effort to save themselves in the future. Thank you.
Want to answer as soon as possible, or we try to
Let me just see if I heard your question correctly. How can we motivate the people to do something? Okay, that's a great question, because that's where it's very difficult, because we're asking people to pay up front, to do stuff in advance when they don't know when it's going to happen. It's so much easier just to wait until it happens and hope you're going to survive, but that doesn't work. And so we're asking people to pay up front. And I think the most important way to do that is to ask them to do one thing. Ask them to do one thing that will make their city or community more safe. One thing each year. It could be the same thing, but if everybody starts thinking that way, then you change the level of consciousness in the community. People are thinking, what one thing can I do to make this place safe? And then you have an opportunity to share that. You have community meetings where people can share what they did, the one thing that they did to help things be more safe. And some people will do big things, some people will do small things, but it doesn't matter. They all have to do something.
Thank you very much for the answer, sir. It's crystal clear.
Okay, for the next questions behind you. Okay, please. Tell me your name and your class.
Okay, thank you for the opportunity and thank you for your presentation. It was great presentation. Before that, let me introduce myself. My name is Ajeng Adinda Putri. I am a student, last year student on Department of Geophysics, STMKG. I would like to ask about the seismic gap in Sumatra. I have do research on the correlation among earthquakes in the seismic area north of Siberut Mentawai in Sumatra. The last major earthquake occurred in 1797 and 1830 and 33, both with magnitude above 8. Then for nearly 300 years, there were no significant event until 20 and 22, until 20 and 23, when several earthquakes with magnitude above 6 occurred. The most recent in 20 and 23 had a magnitude of 7 and even generate a small tsunami, although it was only 11 centimeters. Since that event, there hasn't been any significant earthquake activity. So my question is, could this area still be considered a seismic gap? And based on this pattern, does it indicate a potential earthquake threat in the future, considering that major seismic activity was concentrated only in 222 and until 223? Thank you.
Okay, Prof. Harun.
Such an awesome question. So good. Thanks for doing your homework. That was awesome. Yeah. So,
Thank you, sir.
as you know, as a geophysicist, the difference in one number to the next in the magnitude scale is an order of magnitude. And so a magnitude 6, even a magnitude 7, is not going to release the energy that has been stored. If you have 30 meters of energy that's been stored, like probably in the Padang section, and you have a magnitude 7, it's going to release maybe a half a meter or a meter of that 30 meters. And so you could have several magnitude 6s and 7s, but it's not going to affect the overall magnitude of the megathrust earthquake. And the occurrence of these events you talked about are probably like foreshocks to the big shock. We notice that not always, but commonly you'll have small events accelerate right before you have a large event, because the large event is starting to cause rupturing of the rocks. So my forecast would be these small events are actually telling us that we're in more danger than less danger. Did that answer your question?
Yes.
Okay.
Thank you so much,
Thank you.
sir.
Thank you so much. For the third questions, please. Want to ask? Please raise your hand. Maybe from the lecturer, Dr. Iman, Dr. Karyana. Do you want to ask something? Or there is any students who want to ask? Yes. Hey, Adit, sorry, in front. Please, yes.
First of all, I want to say thank you so much, sir, for the opportunities and the presentation. First of all, I want to introduce myself. My name is M. Aditya Hafiz. I'm from Geophysics Department in second semester. I want to ask you a question. From my personal experience in high school, I don't think in the Indonesian curriculum has implemented more about evacuation or more about hazard safetyness, even though we are a place that can easily be hit by a massive earthquake or tsunami. I want to ask your opinion about, do you think implementing more about mitigation and hazard awareness on schools starting from the from the elementary school until high school, do you think it's one of a great idea to help our fight against this natural disaster? Thank you, sir.
Very good questions. You guys are asking great questions. I think children getting involved is one of the most important things we can do to raise a new generation which has a new awareness. One of the biggest problems is that right now, Java and Sumatra are in a lull of seismic activity. They usually have a lot more earthquakes than they have had in the last 20 years, which means eventually that strain has to be released. So we're going into a phase of higher seismicity than we have had in the last 20 years. And so we need to let the children know that just because in their lifetime they haven't felt an earthquake doesn't mean there's not going to be one. And by having earthquake drills on a regular basis, this is one of the things we're going to try to assess when we go to Ambon. When we go to Manado and when we go to Ternate and when we go to Sumatra. We're going to see if they're having regular earthquake drills and tsunami evacuation drills. And just document if they are or if they're not. I mean, if they're not, we're going to try to advise them to do that. What would you recommend that they do at that school level that would help the children?
In my opinion, sir, I think we should implement more on the drills on how we prepare ourselves when a massive earthquake or tsunami come. Because in my experience myself, I haven't had any drills on how to anticipate an earthquake or tsunami from elementary even until high school, sir.
Where do you live? Or where are you from?
I'm from South Sumatra.
From where?
South
Oh,
Sumatra.
South Sumatra.
Yes.
In the western part?
Not really.
Wow. And no drills of any kind.
Yes.
Thank you so much for the feedback. Yeah.
Thank you so much for the answers.
Thank you so much. This is very interesting question and answer actually. Now for the second session, maybe we can give opportunity for the lecture first. Maybe Miss Dr. Iman or Dr. Karyono want to ask, and Miss Evanista, yeah. Do you want to ask something from lecture? Or yeah, Dr. Iman first. Oh yeah. Okay, for the student first then.
What? At first, let me introduce myself. My name is Dava. I'm from final year Geophysics Cadets. At first, I want to appreciate your representation, and I want to ask you about the seismic gap, especially in the southern of Java until Sumba Island. You say about the seismic gap about that part. Now, I want to ask you about how do we can differentiate between seismic gap and creeping zone, sir? Thank you. How do we can differentiate about seismic gap and creeping zone?
You mean like a creeping zone?
Yes.
Okay. Very good question. Awesome question. You guys are, I could sit here and listen to you guys forever because you've thought about this, which is awesome. So the way you can tell is by doing a GPS survey and also by looking at seismographs that are seismometers that are set up. Even with creeping earthquakes, you have creeping fault zones, you have small earthquakes like magnitude 3s, magnitude 4s, constantly, right? Whereas when the subduction interface is stuck, you can still have small earthquakes, but you're having deformation of the upper plate. Whereas with creep, you don't have any deformation at all because none of the activity or very little of the friction is actually causing deformation. There's very low friction. So the GPS will show you if there's deformation. For example, lots of people have said that the Java Trench is creeping because there hasn't been a big earthquake for 400 years, right? So it must be creeping. But there's huge amounts of deformation in the southern mountains of Java, in both south of Bandung and south of Jogja, where you have uplifted coral terraces, where you have streams that are trying to cut down through the mountains, but the mountains are rising too fast for them. So the deformation is telling us that it's stuck. Without deformation, creep would be fine. And Hanif has something he'd like to say too. Thank you for that great.
Thank you, sir.
Thank you. This is not related to your question. I think, yeah, you can sit back. I'd like to ask a quick survey, I guess. Who lives close to the beach here, or like an ocean? Okay, 1, 2, 3, 4. Okay. Okay, now put your hands down. Who has experienced a tsunami drill? 2, 3. Okay. I was just talking to Dr. Harris. I was whispering to his ears, hoping that he will say it as his own words, but he asked me to say it by myself. So maybe since only like a small amount of the students here or the cadets here experience tsunami drills, maybe STMKG, mohon izin Pak Iman, maybe STMKG sometimes can do a tsunami drill or like a fire drill here. Yeah, that's.
Actually, from STMKG you also have like a tsunami drills, also earthquake drills in elementary school or like a middle school here near here, or sometimes in there. Actually, this year we have like a PKL, right? in the station in Indonesia, so they have also have opportunity to share about tsunami drills, also for earthquake drills, evacuation at the same time. So that's why we also have some opportunities to have experience like that. Yes. Yes.
Well, I would like to challenge you when you're not here and you go back to your home, that you bring the knowledge that you have here to your home community. And if they're not doing earthquake drills, you need to help them start. If they're not doing, if it's near the coast and they're not doing tsunami drills, you need to help them start. You're the person now. It's not just going to school so you can get a job. When you go to school, you all of a sudden have responsibility to share your knowledge. And each one of you comes from a different part of Indonesia, and most of those areas have some kind of natural hazard. And if you don't know, then do some research and find out what the natural hazard is for your community and do something about it. It makes your education be real. You're not just learning, you're also acting on what you know.
Thank you, Professor. Is there enough for your answer from your questions? Is it enough? Okay, thank you. Another question maybe from cadet or Miss Dr. Iman want to ask? I think it's
Okay, thank you. I have several questions for Johannes, Professor Rans, about your challenge to cadets. When you go back home, you should explain and try to help the society about hazards, natural hazards. And I said, every cadets, when they go back to their hometown, for example, during long holiday, long vacancy, every semester, yeah, they go back to their hometown and their school in the elementary and high school, yeah, school asked to them. The teacher, somebody was the teacher when the cadets in elementary school and high school asked to them, and can you explain? Can you socialization of the natural hazard and how to sharing or how to face the the natural hazards like that, something like that. And they said, yes, we will socialize and we will explain to student in school, in their school. And after that, they report to us. To the department and teacher, lecturer. I have socialization and I have explained about natural hazard like earthquake hazard and tsunami to my school. That's good, very good. And maybe not the effects not effective, not big, but the minimum we can share the knowledge because they were from all Indonesia, from west to east, as you know, yeah, and only small affect I think, but it is our best try and our best to educate the society, the people, how to face the natural hazards. I think this is my comment, Prof. Thank you very much.
thank you, Dr. Iman. Okay, Prof. Ron.
So one of the best ways to learn is to teach what you know. And that's why I really like what you just said, is because now they become the teachers, right? To their siblings and also to other younger people. And they become the heroes of the community, especially, yeah.
Okay. Thank you for the question and the comment for Professor Ron. For today seminar, our objective for these sessions, in my conclusions, we learn about many lessons about various initiatives across Indonesia, identify potential pathway for the future collaboration, especially about the geohazard and assessment for response and also mitigation in the future. Especially for us in STMKG is the agent of future for the BMKG. That's why we need more action and also more elaborate with another organization for the better future and the better safe for many people. Okay, thank you very much for today and give big applause for today's presentation, Professor Ron. Thank you very much. Yes. Okay. Okay, for the next maybe no, sorry. Operator, can you appoint for the barcode, please? Because we already complete and enough people to do the survey, please kindly scan with your phone and answer the question and or survey this one from Professor Ron, please. Please open your phone and take a picture and give your answer for the survey, please. Thank you. If there are any question, you can ask us in the front. And maybe we can back to the Master of Ceremony for today. Thank you very much. Wassalamualaikum warahmatullahi wabarakatuh.
Thank you, Ms. Ayu Adi Justicia, for expertly moderating such an insightful and engaging session. Your ability to steer the discussion and draw out key takeaways has been truly commendable. Let's give another round of applause for Ms. Ayu Adi Justicia, SST, Magister of Applied Science. Ladies and gentlemen, as we approach one of the most meaningful parts of today's event, we would like to take a moment to express our deepest appreciation. Now we move to the presentation of souvenirs, a token of our gratitude and recognition for the contribution and presence of our esteemed guest. We kindly invite Dr. Iman Suwardi, MSc, to come forward and present the souvenir. And we would also like to invite Professor Ron Harris to come up on stage to receive the souvenir. Maybe on the stage. Okay, thank you very much for Dr. Iman Suwardi, MSc, and Professor Ron A. Harris. And ladies and gentlemen, as we draw close to the end of today's seminar, Bridges over Troubled Waters experiments with full spectrum geohazard risk reduction in Indonesia. I believe we can all agree that it has been an incredibly enlightening and impactful event. We have gained invaluable perspective on the multifaceted challenges and the innovative solution being developed to address geohazard in Indonesia. The discussion today have reinforced the imperative of a holistic and collaborative approach to disaster risk reduction. On behalf of STMKG, I would like to express our deepest gratitude to our esteemed speaker, Professor Ron A. Harris. Your willingness to share your knowledge and experiences has been the cornerstone of this seminar success. Our outstanding moderator, Ms. Ayuadi Justicia, ST, Magister of Applied Science. Your guidance made this session flow seamlessly and productively. All our participants, both in person and online, for your enthusiastic engagement and thoughtful contribution. And last, our dedicated organizing committee, volunteers, and technical team whose tireless effort behind the science made this event possible. We hope that the insight gained today will serve as a catalyst for further research, stronger collaboration, and ultimately a more resilient Indonesia, the bridges we built today. Through knowledge, partnership, and innovation are indeed crucial for navigation the troubled weather that lie ahead. Please stay tuned for information regarding materials and post-event summaries, which will be shared via email. And we wish you all a safe journey home or a productive continuation of your day. Thank you once again for your presence and participation. We look forward to seeing you at a future event. This concludes our seminar. Have a wonderful day and goodbye.